Hello, I'm Sierra, and today I'm going to be talking to you guys about the concept of time value of money. So, the concept that we look at when understanding time value of money is $1 in hand today is worth more than $1 at some point in the future. That could be 1 second, 1 minute, 1 hour, 1 day, 2 days, 3 days, next week. So the question that people ask to understand this whole concept is, would you prefer $100 today or $100 a year from today? So there's three main reasons why we would prefer the $100 today instead of 1 year today. So let's look at those. The first and most important reason is the value of the money is worth more today, which means it's higher than it will be tomorrow. Number two is you can make more with a proper investment, aka diversifying your stocks, knowing what to invest in and when to invest in it and when to pull out of it. And number three, the trustworthiness of the source, so you don't know where that money is coming from, you don't know if that person's going to pay it up, so you would rather have the money today than have to wait for it and possibly never get the money. So the very basic time value of money equation we look at is FV equals PV times 1 plus R to the T. So FV standing for future value, meaning what your investment will be worth in the future. PV stands for present value, which means the principal that you invest, what you start investing with. R can be interchangeable with I, and that is the rate of interest, and T can be interchangeable with N, which is the number of periods or the amount of time you are letting your investment grow. So with that being said, because this is an equation, because this is the basic time value of money equation, we can make an equation to solve for FV, which this is the equation to solve for FE. We can make an equation to solve for PV, which I will show you, and we can make an equation to solve for R as well, and we can make an equation to solve for T. Now, you can also do this on a financial calculator, which most people tend to do because then they don't have to do the longhand math and understand how to fully simplify it and solve the problem. So without further ado, let's get into some examples of solving for FE, PV, R, and T. So as stated before, the basic time value of money equation that we use is FE equals PV times 1 plus R to the T. However, in the real world, most of the time, your interest will be compounding, which is what this bottom equation is, which is FE equals PV times 1 plus R over N times N to the T. So this is more of a realistic application, and it becomes even more realistic when we add in the payment function. However, we will not be going over that today. That is for a later date. So looking at this equation, it intuitively makes sense that there is a positive relationship between future value and time, as well as future value and the interest rate, because it makes sense. The higher the interest rate and the longer you let your investment set, the more money you will be able to make on it. So without further ado, let's just make up an arbitrary problem and work through it to solve for future value. Okay, so this is just an arbitrary problem with arbitrary numbers. I just made them up. So future value is what we're solving for, therefore that gets a question mark. The present value is you invest $2,000 with an annual compounding rate of 5% for 20 years. So you plug it in to the equation and you put FV equals 2,000 times 1.05 to the 20, and that gets you $5,306.60. Now, if this were to compound semi-annually, you would have to divide 5% by 2, which would come out you'd have to divide it by 2, and then you would have to times the number of periods by 2 and adjust it in your financial calculator. However, the problem we went through was just compounding annually because it is easiest to understand and grasp the concepts through that method. So next we will solve for present value. Okay, so on the left, we have the original equation, which is FV equals PV times 1 plus R to the T. And in order to solve for PV present value, we have to rearrange the equation and simplify it to solve for PV. So that ends up being PV equals FV divided by 1 plus R to the T, which makes sense because you're timesing it in the original equation to get future value, and because future value and present value have an inverse relationship to R and T when you're solving for present value, it makes sense. And so present value has an inverse relationship to interest rate and time, meaning the lower the interest rate and the less time, the greater your present value investment has to be in order to reach your future value goal. So let's walk through this problem. So future value we know is we decided that we want a future value of 10,000 for whatever we're doing in the future. We don't know what we need to presently invest in order to get to 10,000, but we know that whatever we invest in, this is kind of a high interest rate, but for interest of the problem, we put it at 10%, and the time amount you have to reach that is in 5 years. So, looking at the equation, we then plugged in all the numbers. So, PV equals 10,000 divided by 1.10 to the 5. And we end up getting negative $6,209.21. Now, the one thing to make sure is when you're using a financial calculator, or just in general to do problems on your own, or to just see what in real life investments, it is noted that one of your values has to be negative, and we normally put either the payment, when you do payments, 2 values have to be negative because your present value has to be negative because that's cash going out of your pocket, and your payment also has to be negative because that is also cash going out of your pocket, and your future value tends to be positive because that is cash coming into your pocket. So in order to get $10,000 in 5 years with an interest rate of $10, we have to presently invest $6,209.21, meaning that is if you just throw that money in and you don't add any payments. However, we're not going over the payment function, so for our interest, it is this amount. So with that being said, let's talk through a interest rate problem. Okay, so the new equation we're looking at is R equals FV divided by PV to 1 over T minus 1. This gets you to solve for the interest rate. So there is a positive association between the interest rate and the future value, which means that the more you earn on your interest, or the more that you earn on your investment, the more that you'll have in the future coming back to your pockets. And there's an inverse relationship between the interest rate and present value, meaning the more you earn on your investment, the more you earn on your investment, the less money you'll need to arrive at the target in the future amount. So the problem that we're going through is a little bit unrealistic because of the end interest rate, but this is a moment in time where your payment function would be really, really good, because then you'll understand that you can invest less, put payments, and still get more. Or compounding interest will also help in this time, because very rarely will you see anything with this interest rate, but these are just arbitrary numbers, so it doesn't matter. The realistic of it, it's just to learn how to solve it. So your future value is going to be set at 2,500. Your present value is going to be set at 500. Your interest rate is what we're solving for, and your time is 10 years. So Putting that all into the equation, we have R equals 2,500 over 500, all to the power of 1 over 10 minus 1. Again, this is where it becomes almost nearly impossible, but it is an arbitrary problem, and some stocks do give you a high return on your investment. However, these are the very risky ones, and we don't recommend that you actually do use these. But all this equation comes out to be a rate of 17.46%. In order to get this interest rate, you have to know how to invest money. But again, these are just arbitrary numbers, and this is just how to solve the problem. So the final and last problem we're going to go through is time. Okay, so the last and final problem we have is to solve for time. Now, most of the time you'll see people using these calculations. They will be using a financial calculator just because the math is really hard and tricky to do it longhand and by itself. But the equation is T equals the natural log of future value over present value divided by the natural log of 1 plus R. So let's look at the same problem we did while solving for rate, but look at a little bit more realistic of a problem with it. So again, our future value is set to be 2,500. Our present value is set to be 500. Our rate, which is more of a reasonable return rate on stocks, is 7%. And then we're looking at time and how much time will we need to get from 500 to 2,500 with a 7% interest rate. So it is also good to note that there is a positive association between time and future value, and this is why we say time is on your side, because the longer you have to invest, the more you'll have in the end. And there is an inverse relationship between time period and present value, meaning the more time you have to invest, the less you need today to arrive at the future value. So with that being said, we get into the math of it. So it's time equals the natural log of 2,500 over 500 divided by the natural log of 1.07. And with a more realistic time frame, we get 23.79 years. Rounding up, we get 24 years. That will take you to take your money from 2,500 from 500 to 2,500 with an interest rate of 7%. This is more of a reasonable problem. However, this is still not fully realistic, because as a normal person, it is very rare that you will just set your money in to some type of investment pool and not make payments on it in the future. However, we are not covering the payment function today or in this week, so that will be for a future. See what I did there? That will be for a future time to talk about the payment method, but more than likely you'll be putting in $100, $50, $200, $250, some amount of money you will be putting in every month so that you can get more money on your return in less time, because who has 24 years to wait? Unless you're young and you start investing, then you have 24 years to wait. But very rarely do you just stick an amount of money into some type of investing and not add more money onto it. So I hope you enjoyed this time value of money application how-to video. I know it's a little bit long, but I wanted to make sure we talked about everything and understood everything. And thank you for watching, and have a good rest of your day.